Hi everyone, welcome back. If you are building AI applications locally, you have probably used tools like Ollama to run open source models on your laptop. It's fast, easy, and great for prototyping. But when you want to move from hobby script to a production ready software system, hitting a local model endpoints directly create a big challenge. Your application codes get locked into Windows specific API formats, and you have no standard security and virtual API keys or access controls. You can't easily track token usage and enforce budgets or switch to cloud models without rewriting code. In this video, we are building a clean enterprise grade AI gateway setup. We'll take a Google's new Gemma 4 open weight family, run it in our local Ollama, and put a dockerized LiteLLM proxy with the PostgreSQL in front of it. By this end of this video, your application will talk to standard OpenAI-compatible endpoints using virtual API keys while running entirely on your local machine. First, let's look at the inference engine Ollama. Ollama runs natively on your host OS and handles hardware acceleration and model downloading and local execution. And Google's Gemma 4 model family gives us options tailored for different hardware capabilities. Like a Gemma 4 E2B, the E stands for effective parameters. It's super lightweight edge model designed for fast response, low RAM usage, and quick testing on standard CPU laptops. And Gamma 412B, a dense workstation model that provides higher reasoning and multi-step planning and stronger coding performance when you have a dedicated GPU or more RAM. To get these models on your host machine, open your terminal and pull using Ollama. Like type Ollama, pull Gamma 4 E2B. So if you want to pull E2B model, Gamma 4 E2B model, just Ollama pull Gamma 4 E2B model. That will pull the E2B model. And if you want to pull 12B model, same way you can pull 12B model. Gamma 4 12B. So this will pull the Gamma 4 models to your local. So to test this model, you can simply run Ollama run. Let's run the E2B model. It's a small model. Gamma 4 E2B. Yeah, it's starting. Let's ask, what is LLM? So here we can see the thinking process. So here is our output. So now we can able to successfully run a Gamma 4 model in our local. So let's see how can we call this via Postman. Let's close this. So here Gamma 4 is running on top of Ollama. So Ollama is running in the background, and as a service. And whenever we call it via HTTP, it will automatically run that part specific model. We no need to manually run any specific model. Let's see that. So here we stop the process of running Ollama Gamma 4, and I'm trying to call this Ollama when Ollama service for model Gamma 4 E2B. So here this postman call, the post call, what I'm trying to do is like I'm calling localhost 11434 API chat. Currently the Ollama service is running on this particular port 11434, and I'm asking I'm calling the model Gamma 4, asking some question like explain what a REST API is in one sentence. Let's call this. So we got the response. This is the thinking process, and here is the response from the model. The REST API is the architectural style that allows different software applications to communicate with each other over internet by requesting and exchanging data using standard HTTP methods. So here what we did, we directly call the Gamma 4 model via Ollama service. Now, instead of pointing our front-end applications or back-end microservices directly to localhost 11434 or Ollama service, we place LiteLLM Proxy in the middle. So what do we do this? For standard API schema, LiteLLM exposes a standard V1 chat completion REST API endpoints. Your code uses a standard Open API SDKs or HTTP libraries or central governance and persistence. With PostgreSQL running behind LiteLLM, we can centralize the virtual key management and user roles and cost tracking and rate limits, and provide a flexibility. If you ever decided to swap a local Gamma models for Claude or Gemini or OpenAI in production, you just change a single config line in the gateway. Your application code never need to be changed. So let's see how to configure this LiteLLM. LiteLLM requires a database, a PostgreSQL. So we are configuring a PostgreSQL. So I'm creating a Docker Compose here to create two things. One is PostgreSQL and second thing is LiteLLM. So here we are configuring the PostgreSQL DB and then LiteLLM. LiteLLM is a open source AI gateway. So we are pulling it from the open source image, and we are running it in a port number 4000, and we are configuring to the database which is running in this Docker. So it requires two things: master keys and a salt key. That we are here right now. I'm configuring some RAM 1234, but we should use a strong keys here. So let's run this Docker Compose. So now what it will do, it will run the two services. One is a database, PostgreSQL database, and LiteLLM. So it's running, it will take a little time. So it will pull the image, and then it will run the schema, database schema, that will create a database and create tables. It will do all those things in the initial setup. So it started. Let's navigate to browser. Let's open localhost 4000. So now we are running it in a 4000 localhost 4000. It opens the LiteLLM API Swagger file, and to navigate to UI, admin UI, we need to navigate to UI path. So this is a Swagger file, and here it is a admin UI. So virtual keys, these virtual keys are nothing but it will help us to control the applications to call the end models. Maybe I'll explain about entire LiteLLM in a separate video. Let's focus on model setup first. So model configuration, we need to go to models and endpoints. So right now we haven't configured any models. That's why all models are empty. Let's add a model. Provider is Ollama chart. Ollama chart is our provider. And what model we need to onboard? We need to onboard a Gemma 4, right? Here what we did. Let me show you what we have installed here. Gemma 4 E2B. Let's work with Gemma 4 E2B. Gemma 4 E2B. And for authentication, first API based URL. Let's give a Docker one. I have you. Notice here we have host.docker.internal instead of localhost. Actually, this allows LiteLLM container inside the Docker to reach the native Ollama service running in our host network. That's the reason we are giving the host.docker.internal here instead of localhost. So let's test it. Actually, this will call the chart completion endpoint and wait for response. So as the model is running in our local system and it's running on my CPU, it's a little slow. That's the reason it's taking time. So it's successfully connected. And here, this is the model name, and we can set up our model name also, custom model name. What I mean is here instead of a Gemma 4 E2B, we can set up a Gemma 4. Just Gemma 4 also fine. Or if you want to set up a Gemma 4 Gemma underscore for that, and however you want to set up, you can set up the public model name Gemma underscore 4. That also you can set up just public name. Add model. So model has been added. So let's call from Postman. So here I'm calling. I have this call Postman already set up here. What I'm trying to do is like I'm calling the V1 endpoint, chart completion endpoints. My local host 4000 on port number 4000, LiteLLM is running. So we're calling this chart completion endpoint. And in the header, we are passing the authorization. Authorization is barrier and the token. Here, currently I'm doing what I'm doing is like I'm passing the master key. The master key is nothing but what we set up here. This master key, I'm passing this as is. So if I won't pass this one, we'll get the authorization error. So we'll get the authentication error. So no API key is passed. So, and another thing is in the body, we are passing the model name. We are passing the model name as Gamma for what we set up in the LiteLLM. And I'm asking a question and I explain what is a LiteLLM proxy is in one sentence. Let's see. So here is the response. The LiteLLM proxy acts as a unified API gateway, allowing developers to interact with and manage multiple multiple large language models through a single standard interface. So we got the response. So what happened now? We call the LiteLLM proxy, and that calls the Gamma 4 model, which is running in our local Ollama, and get the response. That we can see that transactions also. We can go to logs and see the calls or calls. What happened in the logs? So that's all. Let's wrap up what we accomplished today. We pulled Google's Gamma 4 local models into our Ollama, and we deployed a dockerized LiteLLM gateway backend by PostgreSQL, and we dynamically registered our models using LiteLLM Web UI. And finally, we verified that our client apps can now interact with local OpenAI weights LLMs using enterprise-ready OpenAI-compatible APIs and virtual key authentication. This architecture gives you a total data privacy with local execution and paired with the governance and stability and clean design for modern cloud microservices. If you find this tutorial helpful, hit the like button and subscribe for more enterprise AI architecture guides. Thank you for watching and happy coding.